chemistry. Okay, so we have matter here. So everything's made up of matter. Okay, it can divide in two ways. All right, so on the left side, it doesn't matter what side we put this on, but this would be mixture of matter, and then this is called a substance. A lot of times we call it a pure substance. So we think of something pure, it's 100% one thing. So we think something pure, that there's not any impurities in it. So we have matter, and we can say it's either a mixture or pure substance. It's got to be in one of those two categories. So the mixture, there's two types of mixture. One where we have even distribution, and then one where we have uneven distribution. So this would be, for example, we could say heterogeneous. That's what that mixture is going to be, and then this is going to be homogeneous. Okay, so heterogeneous is uneven mixing. That's a really simple way in which to do that. Uneven mixing, and then this is even mixing. So if it's evenly mixed, then we know it's got the same distribution of the particles throughout. It's evenly distributed equally. So this room is not considered an even distribution. Now these desks might be a little bit closer to that, but even these desks are not probably an even distribution. Even distribution is kind of really tough to show, but I'm going to have you guys do an activity where you're actually going to look at pictures of particles and molecules and determine if it's an even mix or an uneven mix. Okay? Most things are an uneven mix. Another name, do you guys remember what the other name for homogeneous mixtures would be? Because there's another name we use in chemistry a lot. So it's a combination of two substances that are mixed together that it's hard to differentiate between the two. Remember what that's called? Solution. So a lot of times homogeneous is the same as, if I say a solution, then we know it's homogeneous. We know it's evenly mixed. Because a solution has to be evenly mixed. Just because the motion of the particles make it that way. Air is a solution. Okay? So then, pure substance, we have two ways in which to look at a pure substance. Okay? So one is elements. So we have the periodic table, we have the mixture, we have up there the elements on the periodic table that we can take a look at. And those are more, I would say, pure when we take a look at how they're made up. It's going to be of one element. So elements would be one type of atom. Okay? Like a hydrogen atom or a carbon atom, but it's going to be one type of an atom. Okay? And then we've got a pure substance also that can be considered a compound. And that's when we have two or more atoms bonded together. Okay? Okay, so that's everything that can be in those four categories. Some sometimes I look at this and I don't know if this is probably good for me to say one type of atom, because elements are made up of different atoms, right? What do we call those atoms that have a different number of neutrons from one atom to another?
Ion?
Close.
Isotope?
Isotope. Now, when I say one type of atom, it kind of is like there's only one type of isotope, but that's not the case. When I say one type of atom, it would be the one. It would be saying that all atoms, like of carbon, then would be 6 protons. So every atom of carbon has 6 protons. Sometimes the neutrons differ. Okay, but a lot of their physical and even chemical characteristics, even if they vary by a neutron or two, they're really similar when it comes to their reactivity and their character. So I'm okay with saying one type of atom there. Okay. Now, matter can also be broken down into a solid, liquid, and gas. That's a lot more general. This is a lot better. This is more specific. So at the end there, it says, hey, we got the classification of matter, and kind of, goes through that. What I want to talk to you about here next is a way in which you're going to do a lab tomorrow. Start thinking about the lab tomorrow and maybe start doing it on Monday. And it has to do with separation of a mixture. How can we separate a mixture? And these are physical separations. Okay, physically separating a mixture, either homogeneous or heterogeneous. Okay, one of the two. And so there's multiple ways. Maybe you guys can tell me the ways that they're saying, and we can give a little bit of detail to that. So when we take a look at separation of mixtures, what are the ways in which you can take something that's impure and purify it to where you can separate it into the elements and compounds, possibly. So what are some of the things that are listed on page 29?
Heating.
Okay, so heating would be a process called distillation. What property do they look at so that they can separate one substance from another when we talk about distillation?
Talking like boiling points?
Yep. So when you have a mixture, every part of that mixture retains its original properties. It retains its original boiling point. It retains its original freezing point within that mixture. So what we can do, we can separate that mixture based upon what's called volatility. Now, so what does it mean by volatility? So if something's really volatile, it means it evaporates really fast. If something's not very volatile, it means it doesn't evaporate as fast. So it would have a higher boiling point. If it's highly volatile, it means, like a lot of organic solvents, they will go from the liquid phase to the gas phase fairly easily. So distillation is a process of separation of a mixture based on volatility. So you'll hear this, it should be VO. So you hear sometimes when we talk about something being volatile, higher volatility has a lower boiling point. Okay, and vice versa. If it has a lower volatility, it's going to have a lower boiling point, or higher boiling point. So things with high volatility will boil first. Okay, so I may show you that here as you're doing your lab. I can set up a little demonstration of a distillation apparatus, kind of something really similar to page 29. This is how, for example, crude oil is separated into its different components to be used. So you may use this in your lab. You won't use that apparatus there. Okay. So if you have a solid that can be left behind, then you can still use distillation. Does that make sense? So if we have something that's solid that's dissolved in something else, it's solid form, it's not very volatile, so it's not going to boil out. It's going to be left behind, and the other substances that are more highly volatile will be evaporated off. Okay? What's another thing they got listed there? It's real simple.
Filtration.
Filtration. So the next thing is if we've got a solid and a liquid together, we can go ahead and do a process of filtration. Okay? And so you'll have some filter paper or something that you can use, and what happens, the filter paper will catch the solid but then let the liquid go through because the liquid's particles are too small, and they'll just pass right through. And the last one, which you guys will not use in your lab, which is probably more important than these two and more used than these two, is a process called chromatography. So, and I looked some information up, more information up on chromatography, and I think you'll be interested in it. I haven't really talked about chromatography, but it's a little bit used in forensics, for example, in identifying substances. It's part of the process, not the whole process. It's called chromatography. And it's a separation that is based on a fluid's mobile phase. Okay, so what does it mean by a mobile phase? So what happens is some fluids move quickly through a material, say a solid material, more quickly than other substances will. So they call, all these substances have this thing called a mobile phase, which they will pass through a solid at different rates. Okay? Just because of their makeup. We're not going to get into all specifics about that. And so I thought it was really interesting that if it's more mobile, it's going to pass through the solid phase faster and go quicker. And it's going to get to the finish line quicker than if we have something that's a slow mobile phase. They also talk about in there about another phase in which it's passing through, and it's called a stationary phase. So a stationary phase would be like a filter paper. You guys would turn over to page 30. Okay, so on page 30 you have a piece of dye or ink that's placed on a piece of paper, and then that paper is dipped into a solvent that evaporates quickly. And then what happens is we can look to see which one travels faster in its mobile phase. And if you look at the dye, which one travels faster?
Yellow.
Well, the yellow comes out, but it looks like blue goes up farther.